Hi guys, welcome to my math and physics hub. But this time we're going to talk about the chemistry question. What is the bond angle in water molecule? Okay, suppose this is a water molecule, and this is hydrogen atom, this is hydrogen atom, this is an oxygen atom. These are electrons, they form a pair, so we call it as a electron pair, and this is also an electron pair. So the problem we are concerning is the angle, right? How many degree is this angle between this bond and this bond? Somebody just told me that it will be 180, right? Look at this, 180 because it's a straight line, so 180 all direction, 180 perfect. But the situation is wrong. This is not 180. Okay, I admit that this somebody was me, exactly me. When I was studying for my A-level test, I thought it was 180, but it's wrong. So this time I'm gonna revenge and hope you guys not make the same mistake after watching this video. So for water molecule, it actually has a situation when these two bonds are with 180 degree in between, but this is only one moment. Why? Because actually, when you are thinking everything in 180, means that this is a straight line, right? This hydrogen will be experiencing three forces from the three parts by Coulomb's law, because all of them are with charge. Those two are with negative charge, and this hydrogen atom with its nuclear is in positive charge, right? So it's experiencing attraction force towards this way, and an attraction force towards this way, and a repulsion force because both of them are positive charged, right? So it will be experiencing a repulsion force from it, right, this way, to my right hand side. So everything will be in equilibrium because to the attraction force, and this attraction force will be combined into this direction, right? Because both of these directions, the divided force will be cancelled to each other. So the combination will be in this way, and the repulsion force from it will be to right hand side. They are equal. So everything here will be in balance. Well, it's perfect, but you forget something. This is only when this molecule is in a planar situation, right? It's no longer 2D. We're thinking things in 3D. 3D means it's in space, and it might be not just in this fixed in this plane. So we know that in our real world, everything is moving. There's nothing static. For this, they're the same. They're not static. So as long as this one moves a little bit, let's say we make it exaggerated a bit, moves to this position, then everything will be changed. Why? Because the attraction force is pointing inside, right? And this attraction force pointing inside. But altogether, those two forces will be combined into a force to this direction, right? Pointing to my backside. And for this repulsion will be pointing outside, right? Outwards. So one is inside, one is outside, but as long as the the distance is different, everything will no longer be in equilibrium, because when the distance got changed, the force experienced by these two electrons, by this hydrogen atom will also be changed. Everything will be changed. So this equilibrium, this balance will be broken. So what's the result? Well, if reform, actually it will move in until everything reaches a new stable and equilibrium, a balanced situation. So what is that? The result is this might move down, this might move down, and this might move down as well, but this moves up. So this will be the result, right? Everything in this way will be no longer able to move anywhere, because all things will be in equilibrium. But so this new bond angle will no longer be 180, but to be this angle, right? You may think, well, obviously it's 120. Okay, wrong again, because this is some geometric problem. We need to analyze it in geometric world. All right, now we can talk about the eventual shape of the water molecule. This is the electron pair in the hydrogen-oxygen bond. right? We're going to talk about this angle. So let's draw the outline here to make it into a tetrahedron, right? So the shape will be like this. Let's suppose this is electron pairs. This is electron pair, hydrogen, hydrogen, and oxygen. They form this tetrahedron with the bond length. All these four, let's suppose they are the same, right? Just to simplify the problem first, to make it a bit ideal. So the lengths of them are the same. Thereafter, with all the four bonds angle the same, we can determine that these four, triangles are three triangles are equilibrium, right? So outside this length, and this all six lengths will be the same. So this is a equilateral triangle, and equilateral triangle as well, right? We quickly make this decision because this is just some geometric problem in secondary school. So we make it fast. Then we just look into this this shape. What we need to get is the angle about this bond, between this bond and this bond, right? And to simplify, we just need to make it into this angle. Right, we just need to know this angle. Then we got a thing solved. We name it as theta, angle theta. And in this shape, we just note this length as b. Okay, so this length will also be b as, and we denote this length as a. This length will also be a, right? So, well, we get, if let's say we got this length, we got this length, then we can definitely get this angle by cosine law, right? So, we're just going to find the relationship between them. But for this shape, we can do nothing yet. The only thing to do is to get something in between to establish a relationship. So here, we know this line will be perpendicular to this surface, right? And this will be the point it intersects with this surface. So let's connect these 2 points. This will be 90 degrees, right? And, well, this is a triangle, and this is a right triangle. So we can make use of this right triangle, right? But not finished yet. We still need to draw a perpendicular line from this point to this line. Why? Because this triangle, we can draw a relationship by Pythagoras theorem. Because we got this side, we got this length, we got this side, we got this side, right? Then this one we can just name it as x, about length of this side. This side is a, but how about this side? We have no idea. So we have to get this side by this triangle, this right triangle, right? For this right triangle, we know it's inside this triangle, and this triangle is a equilateral triangle as well. We draw it at the side. It's an equilateral triangle, and this point is just at the center, right? We connect these two points. It's just like these 2 points, and we draw this perpendicular line. So just like this, right? For this length is b, so this length will be half of b, right? And we know that this is a equilateral triangle, so 60 degrees for all angles. And this line will be dividing this angle into 2 equal parts. So this part will be 30, right? I try to draw this triangle bigger so that you can see it clearly. Right, this is a length with b over 2. And this is 30 degree, 90 degree here. So this length will be b over 2 times 1 over square root 3, right? And this length will be twice this length. So it will be 2 times b over 2 times 1 over square root 3. Which will be a square root 3 with b as denominator. and this length will be b over 2 square root 3, right? So in this shape, we just shift this line to here, which is b over square root 3 length. Then after we get this right triangle, we can establish a relationship in Pythagoras, and this right triangle we can also establish a relationship. So in this case, we can write two equations. First is about this triangle, right? The relationship is a squared equals to x squared plus this b over square root 3 squared, right? And with this triangle, this big triangle, we can make a relationship here with b squared equals to a plus x squared and plus b over square root 3 squared. So we can establish this equations, and with three variables, two equations, we can get a relationship between a and b. Then we can solve the problem. So with this, we just shift this relationship over here. We just need to find out the relationship between a and b. So we simplify the equations first. The first thing, I'm going to shift this x squared to left hand side, and this one I just expand them into b squared. Square root 3 with square will be 3. So this is the first equation, and the second equation, we just shift this b to left hand side, so combine them together. So b squared minus this one, which will be b squared over 3, right? And this one remains right hand side. So this one will be I'll shift this to left hand side and this to right hand side. This will be 1 minus 1 over 3, which will be 2 over 3 times b squared. And we do some further simplification. This a squared minus x squared, well, we're so familiar with this, so we'll just write it to a way that's simplified. So a plus x times a minus x equals to b squared over 3. For this part, as long as we know that x, a, and b are all, positive numbers because they are just lengths, so we just square root for both sides. We get a plus x equals to square root of 2 over 3 times b. And, well, a plus x, so we can just directly substitute this thing with this part. Then we got a square root 2 over 3 times b times a minus x equals to b squared over 3. And below we get a plus x equals to square root 2 over 3 times b. And this 2b can be cancelled, and this thing can be shifted to right hand side, right? So we got a minus x equals to b over 3 times square root 3 over 2, right? And a plus x equals to square root 2 over 3 times b. We do some further simplification. A minus x will become, b times 1 over 3 times square root 3 square root 2, which will be b times this square root 3, and 3 will become 1 over square root 3 times 1 over square root 2, right? And below we get a plus x equals to square root 2 over square root 3 times b. And furthermore, we combine this into b times 1 over square root 6, right? And we times square root 2 to both denominator and numerator about this. So we got square root 6 at bottom, and above we got 2, right, times b. And I treat this equation as equation 1, and this equation as equation 2. So if we combine equation 1 and with equation 2, then we got 2a, right? And this x will be cancelled with this x. So these two will be added together, which is 1 over square root 6 plus 2 over square root 6. So this will be the result. After combination, we do some further simplification, which will be 3 over square root 6. So we shift this 2 to right hand side. We got a equals to b times 3 over square root 6 times half, which is, so this is the relationship between a and b. And we go back to the graph. For this part, we can establish a relationship between a and b and theta by cosine law, right? Cosine law, which is b squared equals to a squared plus a squared minus 2a times cosine theta. So we copy this to here. And here we go. I just simplified and add them together will be 2a squared minus 2a squared and cosine theta. From here, we have the relationship between a and b. So we substitute this b with something about a, right? So we got a bracket square, which is b inside, a times this thing, 1 over this thing, right? So 3 over 2 will become 2 over 3. And this will become square root 6, right? At right hand side will be 2a squared minus 2a squared cosine theta. And this will become 9 times 6 times a squared. Here, 2a squared minus 2a squared cosine theta. The 6 and 9, we divided by 3 for both, will be 4 over 3 times 2, a squared for left hand side. Combine them together, 8 over 3 a squared will be equal to right hand side, which is 2a squared minus 2a squared cosine theta. We divided by 2a squared for both sides, which will become a 4 over 3 for left hand side, and right hand side will be 1 minus cosine theta. So we can easily get cosine theta as 1 minus 4 over 3, which is negative 1 over 3. Well, it's a negative number, of course, because this angle obviously is greater than 90 degrees. So our theta is cosine minus 1 with negative 1 over 3, which will be 109.5 degree. Up to here, well, you just think the angle over here is 109.5 degree. Well, it's perfect, but you ignored something. This is an ideal case. For all these 4 angles are the same, but in real world, these 2 electrons and these 2 electrons, they are free, not like the electrons inside this bond, they're fixed. So they actually will push this bond and push this bond. This one will also push these 2 bonds into the same way. So this angle will become less than the ideal case. Then we can decide the real bond angle. This is actually 5 degrees less than this, so it's 104.5 degree. How about this case? We still can, find something for this case by perfectly symmetrical, which is, mathing. So because here for mathing, you got 4 hydrogen. All of them are the same, with 1 electron inside, 1 electron inside, 1 electron inside, 1 electron inside. Everywhere is the same, but for water molecule, you got electrons right? Electron pairs. They actually have different effects from this. They're not the same, so the effects will be different. The bond angle will be 104.5 degrees. So this is the answer for one molecule. Hey guys, we're done with the solution. If you have any questions to discuss with me, or you want to share some idea, you can just leave me a message or just comment under the video. Hope you guys like my video. If you like it, please subscribe my channel. See you guys in the next video.